Hello everyone. Today I'm making a new movie in order to continue our chapter 5 probability concept. Okay, previous movie we already learned how to find prior probability, conditional probabilities, and joint probabilities. And this is a tree diagram that show us the stage of probability for one problem. Okay, so I expected that, or I thought that you already got these points, the concept, and you can answer or you can find the solution for exercise as homework. Okay, today we should go to new one, Bayes theorem. Okay, Bayes theorem. So this is a new point that we will proceed this movie for today. And okay, for Bayes theorem, I will take table from previous movie, contingency table. Okay, this one, this table. This is the question. We already learned how to answer the question. Question 1, question 2. It is the tree diagram. This is a also tree diagram. We draw it. This is it should be we have in this tree diagram we have 3 stages of probability. This one it should be prior probability. This one could be conditional probability, and this one should be joint probability. So we have 3 stages of probability for this diagram. However, when we study Bayes theorem, we will find the other. We will proceed, or we will extend this tree diagram in order to find the other one probability. Okay, so let's go to see together. Okay, so in this case we have a table from previous table is about asking 200 executives whether they remain in the with the company or they move to new companies. And this is a length of service. That means it could be working experience. So A in this case is event of saying yes or saying no. Saying yes, stay with the company. Saying no, resign from this company and move to the new company. So A1 yes, A2 no. B is event of length of service, I mean working experience. B1 less than 1 year, 1 to 5 years, B2 6 to 10 years, B3 and more than 10 years before. Okay, based on this table, we should have the other question. Okay, based on the earlier contingency table, what is the probability of a selected executive with more than 10 years would remain with the company? What is the probability of one executive selected with more than 10 years of working experience would remain with the company? Okay, so this is a question. So how can we use a label on the question? Okay, this is your label. You can see, is it conditional probability? Is it conditional probability here? Okay, check back. Okay, check back. This is conditional probability. This is conditional probability of the one who says yes, among the one say yes, and more than 10 years experience. Okay, this is conditional probability. How about this one? Is it conditional probability? No, because A is the first event and then B, right? So conditional should be affected from A, B affected from A, but this one A affected from B. Why is it that? So this is not conditional probability, but this is we call posterior probability. Posterior probability is the probability that we use in order to study Bayes theorem. That's why this is not really conditional probabilities. It could be conditional probability, but not the same thing as previous one. This is extended the new probability from our tree diagram. Okay, so based on this table, what is the probability of a selected executive with more than 10 years will or would remain the company? Executive more than 10 years would remain the company. It means would remain the company will affected by more than 10 years. So this is not a conditional probability. This is we call posterior probability. So Bayes theorem was developed by Thomas Bayes in 18th century. Is a method. Okay, Thomas theorem is was developed by Thomas Bayes, 18th century. Is a method for revising a probability given additional information. Revising what? Revise that means re-editing. Revising I mean re-editing. Re-editing the probability when we have additional information. Revise from what probability? Revise from tree diagram. Okay, revise from joint probability. So previous point we calculate joint probability. In this case, if we have new information or we have new question, so we will revise joint probability in order to get posterior probability. Okay, with two outcomes A1 and A2. So it is computed by this one. Okay, I put B, not B1, B2, B3, because we're talking about B is what we want to study. Actually, based on the table, you see, based on table we have B up to 1, 2, 3, 4. But in our question, executive more than 10 years, so we take only B4. So we don't care about B1, we don't care about B2, we don't care about B3. That's why in our formula write this one. So B here represent B4, because this is only for our question. Okay, so B here should be represent for B4, not B1, B2, B3. So B here only represent for B4 only, because based on the question. Okay, this is what we call posterior probability. A posterior probability of I is ordinal number. Okay, ordinal number should be 1, 2, 3, 4, 5, 6, 7 up to n. Okay, so suppose this one is only 2, A1 and A2. That's why I also I1, I2. Okay, that's why this is a joint probability of even B, even A1 or A2 divided by total joint probability. What does it mean? Total, we add all joint probability together. Okay, so the first we call previous movie we don't call prior probability, but now we call prior. Prior is the first probability in our tree diagram. Prior probability is initial probability based on present level of information. So they are probabilities A1 and probabilities A2. Posterior probability, yes, this is posterior. Posterior probability should be prior before, posterior later. That's why we can say it should be the opposite. This is the first probability, this is the last probability. In previous video, in previous video or in tree diagram previous video, last probability is joint probability. But now when we study bias, we have the other one beyond or after joint probability. We have the other probability that we call posterior probability. So it looks similar to conditional probability, but when we study about conditional probability, it should be probability of the first probability under condition. Yes. Under condition of the first probability, the first event, we study about second event. Okay. Normally, when we count, when we read letter our English A, D, right? A, B, C, D, something is. That's why A is always the first, second, third, and fourth. So when we study about probability, especially when you study about conditional probability, under the first event, we try to calculate probability of second event, because second event is affected by the first. Okay, this is we call conditional probability. But look at posterior probability. Why A under condition of B? So is it different? Yes, different order. This is B affected from A. That means A has influence on B. That's why conditional. We study about conditional probability. But this one, why the first letter is affected from the second one? It should not be like this one. That's why this is not conditional probability, but we call this one as posterior probability. So how to find posterior probability? By using the formula. Maybe when you see the formula, it's not easy to understand. It's not easy to understand. And it's not easy to remember, and it's not easy to understand. Yes, I agree with you. It's not easy to understand, and it's not easy to remember. But how to understand this one? How to remember this one? Practice. Practice make you remember this formula. Practice make you understand this formula. Okay, so we go to practice. So based on this question, based on this table, what is the probability of selected executive with more than 10 years would remain with the company? That's why this symbol here. So solution. Okay, this symbol. But in this case, I put B4. Generally, I don't put B4 in a formula, because B is only 1. How about 1, 2, 3, 4? 1, 2, 3. 1, 2, 3 we don't care, because our question not mention about B1, B2 or B4 or B3, but our question is about B4. That's why B here represent B4. So this is specific question because we have B4. Okay, so what is the probability of a selected executive with more than 10 years would remain with the company? Among executive more than 10 years, the one remain the company. Okay, among executive more than 10 years, probabilities are the one remain with the company. Okay, solution. Based on the table, we can find posterior, the first probability. Okay, so probability A, based on the table, you can see that among 200 executive, 120 say yes, remain with the company. That's why probabilities of executive remain the company 0.6 or 60%. And the probabilities of not remain with company, move to new company, is 40%. Okay, this is we call prior probabilities. Previous video we don't call anything for this probability. Okay, previous video we don't call any name for this probability, but actually it is prior. This is the first probability. So we have first probability right now, we have conditional probability, we have joint probability, and we will have new one. This one we call posterior probability. Okay, So we have you. This is Bayes' theorem's probability. So now we find posterior, and then next we will find conditional. Okay, we can get the probability, conditional probabilities of an executive more than 10 years. So among say yes, the probabilities that more than 10 years is 0.625. Among say yes, among executive remain with the company and more than 10 years, they are more than 10 years, this is percentage. Among the executives say no, not remain with the company, move to new company, they are more than 10 years, is this percentage or this probability. Okay, so this is we call conditional probability. You can see A has influence on B because A always comes first based on order or alphabet, English alphabet, A, B, C, D, something like this, right? Okay, that's why A always comes first. So this is we call conditional probability. So when we have prior probabilities and we have conditional probabilities, we can find joint probability. This is from previous video that we study. Yes. Okay, this is joint probabilities. Probabilities of executive say yes, remain in the company and more than 10 years. So in this one, probabilities of executives say no, not remain with company and more than 10 years. This one. Okay, so this is our equation. Yes, this should be not the question. This should be our answer. The probability of selected executive more than 10 years would remain the same as this one. So among more than 10 years, executives say yes, remain company. Okay, this is called Bayes' theorem by using posterior. This is posterior probability. Among executives more than 10 years, and the ones say yes, remain the company. So we got this one. So by taking what? By taking this one. Okay, joint probability that say yes and more than 10 years divided by total. What is total? This one plus this one. So total. Okay, total. So total. That's why we take the probabilities of one executive with more than 10 years would remain the company is the joint probabilities of say yes with remain company and more than 10 years divided by total between these conditional total between these joint probabilities. Okay, so if the question asking not remain, for example, the question asking the other question asking what is the probability of selected executive with more than 10 years but would not remain with the company. So would not remain, it means probability of this one among more than 10 years would not remain. That's why I can say that this is 0.40 multiplied by 0.375 divided by overall here. Okay, what is it? It should be 0.29. Let's say this is 7 and 5. Okay, because when we add them together must be equal to 1. Okay, so in this case, when you know the probabilities are one executive selected with more than 10 years would remain, and you can you want to find not remain, you can just using complement rule or addition. Okay, so this is we call posterior probability from theorem, Bayes' theorem. Okay, this is posterior probability from Bayes' theorem. So again, First, maybe you can ask question, teachers, I don't remember this one, I don't understand this one, why we need to take this one? Okay, so this one is as extend the other probability. So you can see my explanation based on table. First we need to find prior probability, we call it first probabilities, and then we need to find conditional probabilities as second probability. And then when we know first probability and we know second as a conditional probability, if we take them together and we multiply them together, we get joint probabilities. If we take the joint probability to find, if we take this joint probability together, and we can get posterior probability. Okay, posterior probability. So posterior probability is not conditional one. Remember that it's not conditional one. It's not conditional probabilities, because when we're talking about conditional probability, I mentioned again, it should be the first probability give under condition has influence on second probability. So not it should be the first event, not probability, influence on second event. Okay, that's why this is we call conditional. But this one, the first under condition of second, why is it opposite? Because it is opposite, this is we call posterior probability. Okay, so this is the way that it, okay, the way they recognize. This is the first event. Normally they are dependent event. They are dependent event. This is a dependent event. This is a dependent event. But this is conditional probability because A has influence on B. But when we reverse it, B has influence on A. This is the other meaning that we call posterior probability. Posterior probability by using Bayes' theorem. Okay, so to be clear for that one, because some students always ask, how can we recognize this is a conditional probability, this is a posterior probability? So I just mentioned already here. Okay, what does it mean? It means that, what does it mean is 0.7143? It means that if an executive is selected at random from the group who work more than 10 years, from the executive length of service more than 10 years, the probability that executive would remain the company is about 71%. Okay, about 71.4%, or 0.71. Okay, 0.21. Okay, so this is among among the executive who work more than 10 years. If it's like one among this one, if among this group, okay, we just take, in this case, we just take one among the executive more than 10 years. How about 0 to less than 1 year? No, not include. How about executive 1 to 5 year? Not include. How about executive work 6 to 10 year? Not include. This is only more than 10 years. That's 5B4. And remain A1. That's why it is among more than 10 years remain. Okay, under condition that among 10 years would remain. So I think it should be clear enough for you to get this point. But if you're not clear, okay, you can contact me. But I also, yes, this is, I think it should be clear for you, because I'm afraid that you will confuse between conditional probability and posterior probability. Okay, so again, this is, if we draw a tree diagram, it is a previous one that I show you, and we just add a new probability that we call posterior probability. So this is the first probabilities. Among 200 executive, 120 say yes, would remain. 18 say no, will move to new company. Say no, that will not remain. Among executives say yes, 10 more than less than 10 year, less than 1 year, 30 1 to 5 year, 5 6 10 year, 75 over 10 years. That's why in this case we will take, okay, in this case we will take more than 10 year, this one, and more than 10 years. This one probabilities of executive work of more than 10 years, say yes. This is work more than 10 years, say no. But we want to say yes. That's why we take say yes divided by overall. Okay, so this one comes from this plus that one. Okay, so okay, look at this one. I put the same color. This is red, red. This is blue, blue. This is green, green. This is maybe gold, gold, or orange. This is orange, not gold. This is orange, orange. That's why this is consistent to each other. You see, the same color. I make it in order to enable you to choose one. This pair, when we add together, 100%. This pair, when we add together, 100%. This pair, when they add together, 100%. Okay, maybe I use this is red. I use red. Okay, I can use blue, blue with blue, green, green with green, yellow, orange, orange with orange. Okay, so red, more than, this is red for less than 1 year. Red for less than 1 year, you say yes. Red less than 1 year, say no. If you want to find a probability, a posterior probability, I say yes. You say yes divided by together. Okay, together is always equal to 1. So this is we call posterior probability. Extended from this one. Extended from or continue from joint probability. Okay, so I think you have some question regarding to this one. If you have question, okay, drop to me. So we visit the other one. This is the second example. Suppose that a class test we have A1 is even a male student. Let's say 45%. So that's why probabilities are male student in the class 45, 0.45. So if the probabilities are male student in the class 45, so probabilities of female student class, it should be 0.55 because together is 1. B, this is only two prior probabilities, A male, A1 male, A2 female. B is even of test result in fail. How about pass? Oh, we caught the question asking about fail. That's why pass we don't care about. So B just represent the fail test. Okay, fail result test. This is a conditional. It historical found that the failed male student in the test so far 10%, whereas the failed female in the test so far not today, so far that means history 15%. That's why we can say among male so far going to test, even fail result fail is 10%. Among female going to test, result fail is 15%. Based on this one, this is a conditional probability. So again, what is the probability of select fail student is male? Fail student is male. That's why it's here. Among fail student is male, because in the fail group, in the fail student group, we have male and female. But if we select among if we select one student from the fail student group, so what is the probability for male? Okay, in this case. So it computed by using the formula here. So B represent fail result test, A1 male. That's why probabilities among fail result test student is male. Okay, that's why. Okay, this is maybe the other node. This is A1, A1, A1 fail test. This is we call joint probabilities. That's why the same thing is 1, but this one is female. So we only take male. That's why we take male divided by overall. Okay, overall. But this represent the fail test. Okay, the fail test. So certified. What does it mean? So the probability of male student given that he is fail test certified. It means that a student selected from randomly from the class, if he select one student from the class, the probability of male is 45%. This is prior probability. That one, prior probability. Okay. This is we just mentioned, but this is the answer. If he tested and test result is failed, probability that a male student failed it in test is 35. 0.35. 35 is our result here. Okay. So this is the other condition. Back again. So A1 is fail. It's a male in class. A2 is female in class. B represent fail result test. Okay, this is a historical data, and what if probability among failed student is male. That's why we can find that one. Okay, if I ask the other question, what if probabilities of a select of fail result test student is female? So it should be yes, but you can use a complement rule of addition. So it should be what? Should be 0.65. Okay, 0.65 is under condition of fail is one student selected is female. Okay. Okay, sorry. For general form, if an outcome we don't have one to say yes or say no or male or female, but an outcome it should be I from 1 2 3 4 5 6 7 up to n. That's why you can see we divide it by all joint probability together. If you have n outcome, so you must calculate n joint probability. 1 2 3 4 5 6 7 up to n. Okay, where SI refer to any of the n possible outcomes. The class test example are summarized as here. Okay, summarize us here. This is we call events. This is prior probability, conditional probability. Okay, I make a color for you. This is a make color for you because I don't want you to confuse between these two things. Normally, based on experience, some students, I don't know, I can say them they were careless. Some students they were careless. They just look at without careful. They say they are the same. Okay, they just look at this probability symbol and they say they are the same. So they read this without careful. That's why they say they are the same, but they are not the same. That's why I put the color. I put the color in order to enable you to recognize they are not the same. This is conditional one. This is posterior. Okay, so maybe I show this one. It's better. It's overall. That's why this is a male student in the class. Probabilities of male student in class. Probability of female student in class. Male student in the class going to test, the result fail 10%. This is it means this is mean from history, not now. So far, female student go to the test, result fail 15%. If you know If you know the prior probability, first probability, you know second one as conditional probability. If you multiply them together, this will be called joint probability. Okay, so if you add joint probability together, this is probabilities of fail. The probabilities of fail. Okay, probability of fail. So you add them together here. So this is fail of female plus fail of male. This is fail of male. Sorry, fail of male plus fail of female. But if you want to find probabilities among a fail group, this is a fail group. If male, that's why this one. If you want to find probabilities among fail group, if female, this one. Okay, so maybe based on this one, a little bit easy for you to see, to understand. Okay, sometimes information given to you or question given to you, and you asking probabilities of like this one, A under condition of B, probabilities of A under condition of B, or given that B, you need to do this. It is better, easy for you to do this table. But I am afraid that when the question asking, you cannot determine this is a posterior or this is a conditional. This is a posterior or is a conditional. For example, go to the question. Yes, this one. Go to the question. If I am not showing this one, if I'm not showing this one, maybe you have question in your mind. This question is probability, conditional probabilities or posterior probability. So in order to determine whether this probability, this question is a conditional probability or posterior probability, you need to go back to see information given. First, you need to see prior probability. Okay, prior probability. Why? In order to understand what event that telling first. What event that is telling first. What event that is telling next. Okay, what event that telling next. So in this case, male, sex or gender telling first. That's why the probabilities of gender, it should be prior probabilities, and then test results telling after that. That's why this should be second probability. But because based on experience, they say fail male or fail female. That's why it should be related to male and female up above. That's why this is should be conditional one. But they say a probability of selected one fail student. That's why fail is second probability. Why is second probability? Because it tell you the second time. This is the first time. So look at the question. What is the probabilities of selected fail student? Fail is like B. Is male. If male, A. Why B, A? It means, what does it mean? It means that B has influence on A. If B has influence on A, this is not conditional one, because conditional one, the first has influence on second. But why this is second has influence on first? That's why this should be posterior probability. Okay. So this is it. Make it easy. First, when information given, you need to find prior, and you need to understand conditional. And then when you multiply it together, this is we call joint. Okay. In order to study bias, you extend from joint probability by add these together, and then you can find male. Take male divided by total is here. If you want to find female, take female divided by total, you get this one. Okay, So this is easy to look at, but if you draw three diagram, it's not easy like that one. Maybe I also mentioned already from previous one, this one. Okay, why I go up, I go back, go forward, go backward, go forward? Because I want you to be clear for that one. So a table just show you, okay, just show you like a consistent of joint probability. Consistent what? Over 10 years say yes, and over 10 years say no. That's why they are consistent each other. But one say yes, one say no. Okay, that's why you can add this together. If you want to find yes, take yes, divide by all. But how about this one? We have 4. We have 4. How to do this one? So I just mentioned for you. This is red with red. Red say yes. More than 10 years say yes. More than 10 years say no. You join together. Okay. So don't confuse. So when you look at this one carefully, you will understand the table. The table just show you one case. Let's say this case. So we don't care about the other. That's why maybe you think that the value show that I present maybe easy. But how about the diagram? It's not, because we have many. So don't care. Just follow the question asking. Just follow the question asking. Okay, look at the other example. Example 3. Suppose that LS24 is a company producing maybe a computer. Suppose that LS24 is a company producing computer, has 3 suppliers, materials. So 3 material suppliers supply material to LS24. A1, this is we call telling first. That's why it should be prior probabilities. A1 is supplied from Hall Electronics 30%. That's why probabilities of Hall Electronics supplier 30%. A2 supplied from Schaller Cell 20%. So probabilities of a Schaller supply 20%. A3 supplied from Crawford 50%. That's why probabilities of Crawford supplier 50%. Okay, this is prior probability. We have up to 3 events from this one A1, from Hall A1, from Charlotte A2, from Crawford A3. B is next probability, next event. Sorry, not probability. B is the next event. B is the event of chips are defective. Defective, not working. Broken, not working. Chip, that means a small board that we put in phone. We put in electronic device in order to make data or electricity run through part to part. So B is event or chip are defective, not working. Based on this should be prior probability. LS24 found that 3% that supply from Hall. The chip here supply from Hall 3% not working. That's why from Hall supply probabilities are not working 3%. 5% from Schaller cell are not working. That's why among not working, among Schaller supply not working 5%. 4% from Crawford not working. That's why among Crawford supply 4% are not working. This is conditional probability. So question: what is probability that a defective chip was produced by Hall Electronics? Okay, what probabilities are defective chip was produced by Hall Electric? That's why effective among the defective group from Hall, among defective group from Hall A1. Okay, A1 here. That's why this is not conditional probability. This is posterior. So maybe I'm just going through a little bit. Okay, you can find that one. How to get this one? 0.3, 0.03. This is posterior. This is conditional. Because we have 3 suppliers, that's why you need to find 3 joint probabilities. One from Hall, the other one from Schaller, next one from Kraut. If you want to find Hall, this is only broken, not working. That's why 23% or 0.23. It means that if a ship is selected from a random from the ship bin, the probability that a ship from Hall produced and also defective is from Hall produced defective. From Hall produced, not should be n. If I use n, maybe you confuse. From Hall produced are defective. Probability that the ship from Hall Hall suppliers is defective is 20%. Okay, 23%. So defective not working ship example is summarized by table. So this is event A1 from Hall, A2 from Schaller, A3 from Crawford. Price or probability 30%, 20%, 50%, together 100%. Based on experience. Okay, based on experience. Among supply from Hall, 3% not working. Among supply from Schaller, 5% not working. Among Crawford supply, 4% not working. So the prior probability, conditional probability, when we multiply prior and conditional, we will get joint probabilities. Because we have 3 events, that's why we have 3 joint probabilities. This is probabilities of ship not working from all supplies. Okay, ship not working from all supply. So probabilities of probabilities from ship not working from Schaller, 20%. I equal to 1 Schaller, I equal to 2 from I equal to 1 from Hall, I equal to 2 from Schaller, I equal to 3 from Crawford. Together 100%. Okay, this is working. This is not working. This is working. So again, in terms of posterior, they are the same. But this one not the same. This is should be B1 not working, B2 working, B1 not working, B2 working. If not working 3%, working 97%. If not working 5% for Schaller, working 95%. If not working 4% for Crawford, working 96%. This is the complement rule of addition. So when we know prior probability and we know conditional probability, when we multiply each other, we got joint probability. This is probabilities of working. This is not working, this is working. Okay, so if among working group ship, when we select one randomly, this one come from Hall, we got 30%. If among working group ship, we take one randomly, this one come from Schaller, 20%, or come from Crawford, 50%. That's why total is 100%. Okay, so this is not working. This is the table, but you can make it in terms of tree diagram. So what tree diagram look like for this example? Yeah, this one. This is we call prior probability. Hall A1 30%, Schaller A2 20%, Crawford A3 50%. Okay, among Hall supply, 3% not working, 97% working. That's why among the shallow supply, 5% not working, 95% working. Among ground fault supply, 4% not working, so 96% working. That's why we have prior probability, we have conditional. We have conditional probability. When we multiply these two probability together, we got a joint probability. Okay. So this is the yes. So you can see based on this one, I put red, blue, blue. Okay, back to previous slide. This is red, not working, blue, working. So you can see, is it the same here? Look at you can compare this table data to this one. Okay, 23%, 26%, 51%, 23%, 26%, 51%. This is not working. How about working? 30%, 20%, 50%. 30%, 20%, 50%. Okay. Okay, I take the other example. I provide you maybe 4 examples. Why? Because I want you to see again and again different example in order to make you understand this one. This example I just take from textbook. It's exercise number 37 on page 171. So I just short screen. The credit department of Lion department store in Anaheim, California reported that 30% of their sales are cash or check. Cash. 30% paid by credit card and 40% paid by debit card. Okay, this is one. So this condition, this information will give me to find prior probability. Okay, this condition, because this is telling us first, that's why I put this prior probability. 20% of cash. Okay, 20% of cash purchase. 20% of cash purchase. That means buying goods, pay cash 20%. 90% of credit card purchase. Okay. Among pay credit card, 90% buying. Maybe I can explain. What does it mean? 20% cash buying. The customer who come to pay. Among the customer pay cash, 20% buying. Buy. Okay. 90% of credit card purchase. 60% of debit card purchase for more than $50. So what does it mean in this case? It means that, okay, I just analyze for you. Among 100% purchase, among 100% purchase paid by cash, among 100% purchase paid by cash, 20% spend more, 20% spend more than $50. How about 80%? 80% spend less than $50. Okay, so we are interested more than $50. So above less than $50, no, we are not interested. So we care about this customer paid by cash buy our product more than $50. And same thing, Among purchased by credit, 90% buy more than $50. Among paid by the debit card, 60% they buy more than $50. Okay, so this is information that tell us to find prior probability. This is the information telling us to find conditional probability. Okay, so this is the question. Miss Tina Stephen just purchased a new dress, cost 220. The price 220, that means she spent more than $50. So it's her case include our study, because we are interested more than $50. What is the probability that she paid by cash? So she could pay by cash or by credit card or by debit card. But our question, she spent more than $50. What is probability that she could pay by cash? Okay, so I can say this is A, even A. This is even B. Okay, look at the question. Question, because Tina buy 120 more than 50. That's why this is even B. Okay, because even B. So probability is by cash. So even B, probability is by cash. What is cash? I could get A. Okay, probability by cash, given that purchase $50. Okay, purchase $50. So A, I could be, because A by cash saying first, that's why I could put A1. It should be this one. Okay, so yes, this is what I can analyze the cash for you, the for you. Okay, so we can go to so solution. We can assume that A is even, or selling is paid. That when they buy, the sell, when they buy, yes, they paid, we got payment. So A1 is sale gets paid by cash 30%, yes, this one. A2 sale gets paid by credit card 30%, this one. A3 sales get paid by debit card 40% by that one. This is we call prior probability. Okay, B next. B event our sale more than 50%, more than $50. Okay, so the sale more than $50 get paid by cash 20%. This one. So this is a symbol. The sale more than $50 gets paid by credit card 90%. This one. This one. The sales more than $50 gets paid by debit card 60%. That one. That's why this is conditional probability. When we know conditional probability, when we know joint probability, also when we know prior probability, and when we know conditional probability, we can find joint probability. But this is a question. What if probability that Mr. Tina paid by cash for her purchase $120? That's what this one. For her purchase 120 among customer buy more than $50, the one who paid by cash. Oh, sorry. So this one. Okay. 11. This was 11%. Okay, this is a review. I gave you four examples. Maybe you can review again and again and again. Maybe sometimes I'm a little bit faster, but however you can go back to view it again and again, and you can pause it if you are not If you think, oh, this is too fast, or it's fast, you can pause. You can pause and you can continue, pause and continue. Because movie, it's easy for you to play around to see. Okay, this is a review 5.9 on this page. And exercise 170. Yes, this is exercise. Exercise should be no, number 3. Number number 34, number 38, number 34, number 36. Number 34, number 36, and number 38. Okay, this is your homework. So I hope that you can do it by your own. Okay. So now it's time for me to end this movie. Okay, turn to you to watch and study, practice, and answer the homework.